Kia ora Year 11 and 12. This is a video looking at some questions from the Scottish Maths exam papers. They are quite good practice for Level 2 algebra. They're a little bit different, they're multi-choice, but we'll just treat them as if they're not. Okay, so if you want to do these, pause the video as I go and have a go at them before I work through them. Alright, the first question, question number 6 apparently, is to evaluate log to base 6 of 12 plus 1/3 log to base 6 of 27. So it's a straightforward achieved level problem using the log rules. So that's equal to the log to base 6 of 12 plus, right, using the rule that log of a to the power of b equals b log a. So we're going to do this one backwards. So it's log to base 6 of 12 plus log to base 6 of 27 to the power of 1/3. In other words, the cube root of 27. So log to base 6 of 12 plus log to base 6 of 27 to the power of 1/3. So that's 3. Now we're using the rule that the log of a plus the log of b is equal to the log of the product ab. So we're putting this one back together. We're going to get equals log to base 6 of 36, right? 12 times 3, and that equals 2. Right, remember how logs work? 6 to the power of 2 gives me 36. Right, so the answer to that one is 2. Next question. Okay, ABCD is a rectangle with side length x and x minus 2 centimetres as shown. And the area of ABCD has to be less than 15 centimetres. So the area is given by x times x minus 2 is less than 15. Expanding that, x squared minus 2x minus 15 must be negative. We get this. Factorising, x plus 3 times x minus 5 needs to be negative. So looking at a number line, that means that I want values of x that are in here. So x, negative 3 and 5 are giving me my limits of x. But there's a problem with that. My side lengths are x and x minus 2, and I can't have a negative length. So the solution is not negative 3 is less than x is less than 5. It's simply x is between 2 and 5. Okay, now it's fine if you just see that and say that, well, I have to have 2 positive side lengths, so the minimum length must be 2, otherwise I'd get a negative. But we can also get it out of the algebra. And we can do that by putting in another constraint, which is to say that my area must be positive. So we can work with a two-sided inequality like this. So I'm going to show you how that's going to help us on the next slide. Right, but the main answer that you have to get is x is between 2 and 5 centimetres. But we'll look at how we can solve that two-sided inequality. So we've got 0 is less than x, x minus 2 is less than 15. So solving this first, we know that the roots of that quadratic are 0 and 2. So when will this be positive? Will be positive up here for x greater than 2 or for x less than 0. Okay, so if I work with this side of the inequation, that's going to tell me from the algebra as well as from common sense that 2 centimetres is the minimum side length. And then working on this side, I get x minus 2 is less than 15. So that's what we had before, that the x plus 3 and x minus 5 is less than 0. So the solution to that inequality is the values between negative 3 and 5. Right, so the intersection of those two sets are the values that will make my area positive but less than 15. So the answer is x must be between 2 and 5 centimetres. Right, next question, another log one. Right, so we're told log to base 4 of 12 minus log to base 4 of x equals log to base 4 of 6. So we're going to use the rule for the difference, which is that log of a minus log of b is equal to the log of the quotient a over b. So we've got log to base 4 of 12 over x equals log to base 4 of 6. So 12 over what is 6? X equals 2. Okay, nice easy log one. Next question is a quadratic. So we've got 3x squared plus 12x plus 17, and we want that to be expressed in the form 3 times x plus p squared plus q. Right, so what this is a rewrite of an expression by completing the square. So we start by focusing here. So 3x squared plus 12x plus 17 equals 3 times x squared plus 4x plus 17. Now if I complete the square and look at that coefficient and halve it, so I get 3 times x plus 2 squared plus 17. Right, now unfortunately I have added in 2 squared, which is 4, times 3. So I need to take that out so that I don't change the value of the expression. Right, so if you're having trouble seeing why it's 12 and not 4, just look at what we've got. We've got this is equal to 3 times x squared plus 4x plus 4. Right, so we've added in the 3 times 4 by mistake, well not really by mistake, but kind of, and now we've got to take it out. So that means that I can write that expression, just get rid of that bit over there. So this expression equals 3 times x plus 2 squared plus 5. And we're asked for the value of q, so q is equal to 5. One more question. Right, evaluate 2 minus the log to base 5 of 1/25. And so that equals 2 minus, now let's have a look at this, log of base 5 of 1/25. What is that? Well, this is saying that 5 to the power of x equals 1/25. That is how I rewrite the log equation. 5 to the power of that equals this. So x must equal -2. Right. So our expression is 2 minus -2, which equals 4. So the correct answer there is D. Okay, hope you enjoyed those. I'll try and find some more questions from the UK over the next few months because they are really good practice for level 2. Thanks for watching.